Let us discuss converting regular expression to finite automata, that is non-deterministic finite automata or Thompson construction. Coming to the first rule, the empty expression epsilon. How do you draw the transition diagram? Here empty expression is epsilon. We have two states, starting state S and final state F. A starting state S looking at empty expression epsilon reach to the final state F. Next, a symbol A of the input alphabet. Here input is A, creating a starting state S and final state F, transition S to F as given in the symbol A. Third rule, union expression. In this union expression, we have two input S and T. Union expression can be represented as S or T, S plus T or S union T. Coming to the diagram, the construction of the machine capital N is shows the transition from starting state S and final state F. It must begin by going to Q1 or Q2 on epsilon. If path goes to Q1, it follows the path in machine N of S and goes to the state F1 and then final state F on epsilon. Similarly, if path goes to Q2, then it follows the path in machine N of T and goes to the state F2 and then to the final state F on epsilon. Coming to the example problem, here A plus B is a union expression. In this transition diagram, starting state 0 and final state 5. First, it should start by moving either state 1 or state 3 when there is a epsilon transition. If path leads to state 1, it continues by following the input A to reach to the state 2 and then state 5 through an epsilon transition. Likewise, if the path goes to state 3, it continues by following the input B to reach the state 4 and then proceed to the final state 5 through an epsilon transition. Next rule, the concatenation expression. The initial state is S by some input N of S to the next state. The transition from this state to final state F will be on receiving some input N of T. In the example AB, we are in a state 0. When we receive an input A, we move to the state 1. Then we receive an epsilon transition, move from state 1 to state 2. Finally, the transition from state 2 to state 3 happens when we receive an input B leading us to the final state. Here, the two answers given here are same. Follow any one of them. Here, the initial state is 0. By looking an input symbol A, the next state will be 1. Transition from state 1 to state 2 will be on receiving input B. Next, fifth rule, the clean star expression or clean closure. The machine N of S shows that from starting state S to Q1, there is a transition on receiving epsilon. Similarly, from starting state S to the final state F, on epsilon there is a path. The path exits from F1 to Q1 is a back path epsilon. Finally, transition from F1 to capital F final state on receiving epsilon, the total recursion is possible in this transition diagram. In the example A star, there is a transition from state 0 to state 1 upon receiving an epsilon input symbol, and likewise there exits a path from state 0 to final state 3 upon receiving epsilon input. A path is established from state 1 to state 2 on looking a symbol A and backward path upon receiving the epsilon input symbol. Similarly, a transition from state 2 to state 3 occurs upon receiving a epsilon symbol. This recursive behavior allows for sequence such as epsilon, A, AA, AAA and so on for the input A star. These are the 5 rules for converting regular expression to finite automata. Now we will move to the first problem. The problem is construct epsilon NFA for the regular expression a plus b raised to the power star ab. The given regular expression has two input a and b in which a separate transition diagram should be drawn for both input a and b. Then union closure concatenation should be done. Take the input a, assign it to R1, then we need to draw the transition diagram. How do you draw the transition diagram? Starting state and final state. Starting state, looking at symbol A, it reaches to final state. Next input symbol B, which is assigned to R2. Now we need to draw the transition diagram. We have two states, starting state and final state. Starting state, looking at symbol B, it reaches to final state. So we done A part and B part. After that, we need to perform the union operation. Look at the question, a plus b raised to the power star ab. So a, b, we are separately drawn the transition diagram. Then we need to perform a plus b, union operation. So R1 plus R2. Because a is assigned to R1, b is assigned to R2. Then perform the union operation R1 plus R2. Combine these separately drawn A and B transition diagram. Create NFA fragment for A and B separately. Create a starting state and final state. Connect the starting state to the start state of both fragment through epsilon transition. Connect the accepting states of both fragment to the new accepting states through epsilon transitions. Next, so we finish the union operation a plus b, then do the closure operation a plus b raised to the power star. That is, a is assigned to R1, b is assigned to R2. So R1 plus R2 raised to the power star. Connect the final state of the union operation to its starting states through an epsilon transition to allow repetitions. Similarly, there exists a path from starting state to final state upon receiving epsilon input symbols. This part matches 0 or more occurrence of either A or B. We created an NFA fragment for sub-expression R1 plus R2 raised to the power star, which allows any number of A's or B's to be matched. Here we finished the closure part R1 plus R2 raised to the power star. Then we need to concatenate AB along with the A plus B raised to the power star. Here R1 plus R2 raised to the power star, AB. A we already assigned it to R1, B assigned it to R2. Here you write R1, R2. So R1 plus R2 raised to the power star, R1, R2. Connect the accepting state of the closure operation to the start state of the symbol A. Then a state seeing a symbol B, it reaches to the final state. This part matches the sequence A, B. We create an NFA fragment for sub-expression A, B, which directly match the sequence AB. We concatenated the NFA fragment for R1 plus R2 raised to the power star and A and B. The accept state of R1 plus R2 raised to the power star fragments connects to the start state of A, B fragment. The accept state of the AB fragment becomes the final accepting state of entire expression. Here, two possibilities are there. Either you have concatenate AB or A epsilon B. Here, these two answers are same. You follow any one of them. Finally, we will give the name to each state. Starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In case if you are following A epsilon or B, 9, 10. So this is the way we are representing a name to it, each and every states. Next problem, construct epsilon NFA for the regular expression 0 plus 1 raised to the power star, 1, 0 plus 1 raised to the power star. In this regular expression, we have two inputs, 0 and 1. We need to draw the separate transition diagram for the input 0 and 1. In this second problem, I tell you the concepts. Input 0 assigned to R1. So how do you draw the transition diagram? Here state seeing input symbol 0, it reaches to final state. Next input symbol assigned to R2. A state, starting state, looking at input symbol 1, it reaches to final state. So we done separate transition diagram for both inputs 0 and 1. Look at the question 0 plus 1 raised to the power star. So we finished 0 and 1, then do the union operation 0 plus 1, that is 0 assigned to R1, 1 assigned to R2, R1 plus R2. Do the union operation. After that 0 plus 1 raised to the power star, that is R1 plus R2 raised to the power star. Closure. This part matches 0 or more occurrence of either 0 or 1. We create an NFA fragment for the sub-expression 0 plus 1 raised to the power star, that is R1 plus R2 raised to the power star, which allows any number of zeros or ones to be matched. Next, we need to concatenate with 1. Look at the transition diagram. This part matches the symbol 1. We create an NFA fragment for the sub-expression 1 which directly matches the symbol 1. We concatenate the NFA fragment 0 plus 1 raised to the power star, that is R1 plus R2 raised to the power star, and 1. The accept state of 0 plus 1 raised to the power star fragments connects to the start state of the 1 fragment. Here this part matches 0 or more occurrence of either 0 or 1. We create another NFA fragment for sub-expression 0 plus 1 raised to the power star similar to the first one. The accept state of the second 0 plus 1 raised to the power star fragment becomes the final state of the entire expression. I think you have understood this topic. If you have any doubt, comment in comment box. Thank you.